Hello, everybody. This is the Jacksonville Java User Group, and we're actually doing another meetup jointly with the Google Developer Group of Jacksonville. And we are here at Avality. There we have a bunch of people here that came to the meeting in person, and we also have a few online. So this is being recorded for people who weren't able to make it, and it will be on our channel, the JaxJug YouTube channel. We are very happy to have Paul Parkinson, who drove here from Amelia Island, Fernandina Beach. So let's get started. I leave the stage to Paul. Paul works for Oracle. He does a lot of cool stuff. We will hear from him. I don't want to say too much about it myself. So I hand it over to Paul.
Yeah, so thank you. This is, when I was invited to this, I said, definitely I want to do this in person because I need to get out of the house, and this is great.
Turn on the camera so they can see your face.
Oh, yeah. The money maker. So yeah, it's great to do this again because so I've been working with Java since the day it came out in '96. So I have the notepad open, ready, and just nonstop since then. So I've done a bunch of different languages, and I still do, but just the Java ecosystem and everything, I love it. So it's always my go-to language and what I work with the most. So I've been at Oracle for 20 years now. And the whole time at Oracle, and even before Oracle, my focus was transaction processing. Dun & Bradstreet, it's great to hear that. I've worked with that before Oracle. Anyway, that's been the vein of things. So I was the first 15 years or so at Oracle. I was the transaction lead. So I wrote all the transaction stuff for WebLogic, the transaction engine for that. And then went over to the OKE, which is Oracle's Kubernetes, that part of their cloud, for a couple of years. Then I went to the Helidon team, which is, if you're familiar with Spring Boot, that's Oracle Spring Boot. And then, we also work with Micronauts. So, and then working in transaction processing, even though I was always like in the mid-tier, I was always spending like maybe 50% of my time in the database, and I was doing development, but always presenting and things like that. So the last 2 years I took on this, I became an architect, and then a developer advocate. So, as we probably all know in this room, the developers are making more decisions on the money. So it's not, product management as much as the developers getting right to the developers, which I love because, it's easy. That's what I've been doing for the last 20 years. So, I love this stuff, and, it's great. So that's been my, my role is still developing things on the database side and in Spring Boot, things, contributing to Spring Boot, things like that. But, doing all this, making things simpler. And you'll see my agenda is just like simple, everything, trying to make it, that's the idea. So I did get the gist from all this, but is anybody working like with microservices or like any kind of aspect? Yeah, I know you must. I think our paths are the closest aligned as far as the customers we're working with and stuff. Okay, so because a lot of what I'm going to be talking about here is event and data-driven microservices, since I am coming from that transaction processing, database, messaging side of the house. Okay.
Avality uses microservices and that much.
Gotcha. Yeah, and it's at the point now where it's no, I think everyone's saying, yeah, we're going to use microservices. It's not hype. And then now it's moving into the hard use cases, right? It's like everybody was doing basic stuff. Now they're moving into the transactions and things like that. And that's where so I'm trying to help with the simplicity part of it because it's not simple. Yep. So
soon people are going to start Googling what's better than microservices.
Yeah. Well, serverless is, what I mean? That's the next, and we have focus on that too, but serverless lacks a lot of stuff Kubernetes does. But yeah, for sure. Because like Chris Richardson? Is he the big evangelist guy? And he's one of the first guys to, start being a strong proponent of microservices. His blog goes crazy. And then like a couple of years later, he blogs, microservices are dead. And his blog goes crazy, right? And then he goes into, well, they're good for some things, not for others. And, he's just selling on shock, that type of thing. That's, what I have to say as far as I can't promise anything in this. And then, like I say, I have a lot of content in this. So if you don't want to hear something, just don't worry about being rude and say, keep it moving. Or if you want to interrupt me to ask questions on something, let me know, because it's like 60 slides. I'm not going to hang on to a slide. A lot of slides are 1 second, 2 seconds, but just let me know. Okay. So I'm going to go through like this as far as the agenda. The polyglot persistence and database lifecycle stuff, portability and compatibility. And again, this is all stuff Oracle's bringing to the table. Event-driven architecture and transactional outbox. That's the one that's the strongest feature and thing I'll talk about. I believe distributed transactions, observability, and then this new offering that we just put on the marketplace, which is a backend for Spring Boot. Okay. So the first thing about microservices is just the fact that, if you're not familiar with microservices, the idea is you're breaking, it's the classic thing. You're breaking a massive, you don't have the mainframes. The mainframes went to mainframes went to application servers. Application servers went into SOA, which is more service oriented, but still pretty coupled. And then microservices, the idea is you have this domain-driven design where there's a service for each feature, or a service for sales, a service for this, a service for this. And you try and make them as decoupled and encapsulated as possible. And what's cool about this is you were supposed to code that way all along. That's what I like about microservices, is it's forcing, it's testing the fact that, you have these boundaries now, because that's what you were supposed to be doing. But it makes it very difficult because they're, the friends and family APIs and stuff in the past were there for a reason. So the idea, and speaking to data-driven apps in particular, the idea is each service has its own, isolated data. So the service is only talking to a certain database, or it's only talking to a certain schema, something like that, where it's isolated. And so that's great because you can specialize things. You can have a database that's good for spatial, one that's good for JSON documents, all these different workload types and things like that. But, then you're dealing with a lot of heterogeneous systems. Okay, lots of different vendors and things like that. So that's great because you can specialize, but it's bad because you have all these different things now you have to maintain. Okay, that's the long and short of it. And so what's great about the Oracle database is every single feature out there, every single different type of database, they're on top of it, of course, and they just go ahead and say, okay, there's Neo4j for graph. We're going to make all the functionality Neo4j has. Mongo's, the rules, the JSON document field, we're going to make it so we can support Mongo databases, including the APIs and things like that, okay? And so the idea is you only have to go to one database. That's why it's called converged. But you're still getting that decoupling where you can have, one schema or whatever for each microservice, but you get the specialized, capabilities of a specialized database, but it's all in one spot where you can administer it easily. Okay, so you don't have a million different pieces. And so that goes into HA and all this other stuff that Oracle's had around for decades. You inherit all that goodness. And then on the microservices side, like communication and messaging, where you might have, Kafka put in the middle, and Kafka's used a lot these days, and for good reason. It's a great architecture, but a lot of people are putting Kafka in there. That's a nice decoupling feature. You can bring legacy and things like that, but you'll put it in there, and there's just messages flying all over the place. It's kind of the thing. And so you can get this lack of data integrity. And that's kind of the main thing. Like I said, that's the number one thing I'll talk about really, is the messaging that is in the Oracle database. But you can get this lack of data integrity, duplicate messages out of order, multiple data stores to handle, the copy contagion, duplicates and things like that. And then again, it's complex to maintain because there's so many moving parts. So the idea with the Oracle database, or the strength there, is that you have the data integrity. You can be working across all these different data types and workload types and still have transactional integrity. You have the microservices support I was talking about, and then the APIs you're used to. You just bring them over and you use them on the Oracle database. So we support all the cloud native open APIs and things like that. And then this is kind of showing using the open services, multiple languages, so you can use any language with the Oracle database. There's drivers for every language. Okay. We know what our favorite one is, and that is the one that's strongest in Oracle as well. It's the Java one. It's as popular as Go and all that is. Java's definitely the strongest one for Oracle features and things like that. And then all these different data types that I mentioned: JSON, blockchain, spatial, etc. So I don't know if I won't go too much into Kubernetes, but Kubernetes is what the majority of microservices run on these days. Okay, this is definitely the de facto standard. And so when you're running microservices and have Kubernetes, there are these things called operators that all the major database vendors have. And Oracle has one too, and it helps you with the life cycle of your database. So this is really nice. You just, with a couple lines, you've installed this operator. It's keeping track of your database's health. It's provisioning a database, tracking its health, and doing things like this, scaling, etc. Okay. So now I'm just going to talk really quickly about portability and compatibility. So the idea here being for popular frameworks, like I mentioned, Mongo. This is the example where you can use the Mongo APIs, but you just have the URL that you connect to for the Mongo database points to an Oracle database instead. And so it's completely transparent. So you can take your app that's written in Mongo today, change the URL, and now you're running on Oracle with all this goodness. So, super simple. And now we're trying to get the Mongo crowd, obviously. And then what's really cool, I like about the fact that we have all these different data types and models in the database is you can actually come up with new use cases. And there's just one example at the bottom here where you can do a query across a JSON document, across spatial, and across AI models in the same query because they're in the same database. And you're not doing that in like some microservice where you're calling these 3 different databases and trying to join them together. It's this one nice optimized query. So that, again, that opens up completely new use cases. It's not just compatibility, it's functionality. And same idea for client. We have a client, Kafka client. Whatever your Kafka code is, you change the URL there, the bootstrap server, to point to Oracle, and now you're using the transactional event queues. Now this transactional event queues that used to be called advanced queues are like unfortunately the best kept secret in the Oracle database because they've been around for a long time, way before Kafka. Actually, a couple of the Kafka guys are from the AQ, the original AQ team. But it's been around for a long time. And just by virtue of the messaging system being in the database, you get a number of features. And actually, I'll get into that when we get to this slide. But that's what this is using. So if you change the URL, you're using the transactional event queues, even though you're in the Oracle database, even though you're using Kafka APIs, okay? And then we have connectors and bridges for Kafka as well. So if you're using Kafka and want to do a bridge of messages back and forth between the database, that's possible, okay? Now this is a key one for microservices. So the big, if there's the number one thing with microservices is you've separated your logic into multiple services. And so what you've done is introduced a network. Okay, that's the number one big difference that I would say. And because of that, what you have is, you want to communicate data changes between one service and another. And now that you're doing that over the network, you have to have a mechanism to do that reliably and with certain guarantees. So when you break it down, it's 2 operations, right? You're making a change to data, and then you're trying to communicate that change of data to another service. And so now this is where the transactional stuff comes in. You have 2 operations, and you want both to happen, or neither. And other systems, you can't do that. So if you're using Kafka and Mongo or Kafka and Postgres, that's 2 systems. And if you want to make that data change and message send or receive atomic, you're going to have to use XA. And when you're using XA and two-phase commit, you're using a transaction manager, and it's all this. You got to keep logs for the transaction manager. You have to keep the database in an in-doubt state. So when this is going on, other applications cannot use that data. So yeah, XA, yep, XA and two-phase commit. Yeah. Oh, okay. So XA works hand in hand with two-phase commit. So it's the protocol of setting up locks between different databases. So we're talking about a database you're making a change, and then a messaging system to send the change. And so in older systems and the application managers and the mainframes and everything else, you're using this XA two-phase commit protocol, where you go through the calls the actual protocol is XA. The consensus protocol is two-phase commit. So what you're doing is you're saying, in short, you have two resources, database messaging service. You say, all right, I'm changing data and sending a message. You ask the transaction manager, there's a third party that has to be involved. Transaction manager says to the database, are you okay to make these changes? Database says yes, so now it's prepared or in doubt. And you can't do anything with that data until the transaction manager says, okay, now commit or roll that back. He does the same thing to the messaging system. Okay, this guy's waiting to hear back from me. I made a data change. Says to the messaging system, are you okay to send this message? It says yes. So now the database and the messaging system are prepared. They're in doubt, and they can't be used by other systems. Now, if that transaction manager goes down, or if there's a delay in the network, and that's the key part, if these factors are much more likely in a microservice environment. If there's any kind of delay, then those resources are not going to be usable. And then you're going to get throughput issues and errors back to the user. So in a controlled system, application services, things like that, that's not a problem. You're cranking through, everything's in the same process. XA and two-phase are fine. And even in a controlled microservice environment. But if your microservice environment is dynamic, which is one of the advantages of it, decoupled and dynamic, then you can run into issues with XA and two-phase commit. And so this is kind of the later section, but it's good you bring it up because it's completely related. I'll mention it now. So that's why with microservices, people have been looking at this pattern called a saga, which does not use XA and two-phase commit. And I'll get into that more later, but just remember everything I said about why XA and two-phase is an issue with microservices. And so what we have here is with the transactional outbox, we need something where we don't use XA, or it'd be much better if we didn't need this XA and this extra transaction manager and all the logs and locks I'm talking about. And what you have to do in a system that uses something like Kafka and another database like Postgres or Mongo is two actions. You sit the data into the database, and then you either have a connector like Kafka Connect or Debezium that's automatically listening on those changes and sending those changes out as messages, or you have something else that's similar, something that's polling that. Now that becomes an issue because first of all, it's error prone. And as we see in the next slide, you can, well, let me see. I'll get to the goodness of the transactional outbox. You can't rely on exactly one's messaging. You may get dupes. Okay, so the whatever mechanism that was reading the database to send messages, the database went down, it came back up, and it doesn't know if that message was sent successfully or not. It has to send it again. So now you need to code your microservice to dedupe messages. It has to keep track of IDs and say, okay, I received this message before, ignore this one, so it's idempotent. It's a pain, and there are a lot of scenarios you can't handle, and the ones you can, you have to code to. And so what's nice about the fact that there's a messaging engine in the Oracle database, and it's been around so long, is that you can do both of those actions. You can make the data change and send the message in the same local transaction, not a two-phase transaction. So local transaction is just that, it's local to the resource manager. So you don't need this coordination protocol of two-phase commit. And because they're both in the same resource manager, that's the only way you can do it. And that's what Oracle has, is the Oracle database and the messaging engine. They're in the same transaction. So you make the data change and send the message. If one of them doesn't happen, the other gets rolled back. So it's clean, and you don't have to code anything in your application. And it's great for modernizing your app too, because if you're bringing an old app into the microservice space, these old apps, weren't expecting the possibility of having a duplicate message sent to them. So you're trying to just bring it over, and all of a sudden things are not working. With this mechanism, you don't have to worry about it. You don't have to code to it. So that's probably, of all the stuff I'm going to ramble about today, it's probably the strongest feature in my mind, and especially because it's been around for decades. Like AQ's been in the database at least 20 years. So like I say, longer than Kafka's been out. And in a line, all right, so back to Java coding. Everything I said, it boils down to this one line, which is very unique. So that session there, the underlined line, that session is a JMS session. And the API has a Git database connection on it. So that's completely unique. That's not JMS or JDBC spec. And so you can get the JDBC connection that underlies the JMS session. And so they're part of the same local transaction. And everything's built on that one line. That's all the whole presentation's about that one. And then so we have this built into some frameworks like Helidon. Again, this is like Spring Boot. And here, if you're familiar with JAX-RS messaging, you're listening on a messaging channel that you just put in config. It's very nice. You just have these annotations. You receive the message. If it's this AQ message, you can get the database connection right from it, and then do your database activity, and then send a message back. So this is actually 3 activities in the same local transaction. You're receiving a message, you're doing work, and then you're sending a reply message. And if any of them fail, they all get rolled back. So, and that's the basic event-driven microservices pattern. It's right in that short caption there. And again, this is, it's become more and more common to use event-driven mechanisms in REST or in microservices, especially when you move closer and closer to the database, than using REST. As easy as REST is, with data integrity type aspects in particular, messaging is used more and more. And just messaging has a number of nice features in general that you don't have to deal with different circuit breaker patterns and things like you do when you're using REST. So likewise in Spring Boot, I've just written this. It's not even in Maven yet, but that's the coordinates that will be in Maven in the next month or two, because so many people use JPA for their data access. What's a problem with JPA is that you can't, and this is down to the spec, you can't dictate what connection JPA will use. You can only dictate what data source it will use, right? And so to use the feature that I mentioned where you're getting a message and then getting the underlying JDBC connection, I had to do some work in Spring to tell the JMS listener that's very popular in Spring to use a particular data source connection, and that connection being the one that we got from this call here. And that's the connection from the data source that's used by JPA. Hope that made sense. So what this is doing is bringing it to JPA. Okay. And so, yeah, we're moving right along, actually. It's a lot of material, but I'm making a lot of, covering a lot pretty quickly. So this is the distributed transaction problem or situation I mentioned earlier. And very often in microservices, they move from the transactional scenario that's a classic. They go from the bank transfer, like it's always been the bank transfer. This is the big transactional scenario. When they go to sagas, they always go over to this travel booking for some reason. It's a little easier to explain it, but it's the same idea. You have multiple participants, And if you're going to book a trip, if your flight, hotel, or car, if one of those goes wrong, then the trip is not going to work, and you want the whole trip canceled. Okay, this is the scenario I talked about before, and so this could be done with an XA transaction, but again, in microservices, XA in two-phase. We have the shortcomings I mentioned, so we look at this saga pattern. Okay, and I'm going to come back to this. So let me just skip over that now. So here's the basic. This is the basic flow that I just described for XA and two-phase commit. It's very similar for sagas, but we're not using locking. We're using all local transactions. And instead of the locking two-phase commit protocol, the microservice has to actually implement its own compensation logic. So it's essentially rollback logic, but the user now has to implement that. Okay, so this is pain. This is in microservices, probably data is the biggest. There are a lot of hard things, but data may be the hardest problem. And this data integrity between multiple data sources is the crown problem of data integrity. So just to explain this saga flow, if I can, what will happen is the application will say, I want to begin a saga. Okay, so the travel agency says, I want to begin a saga, and it will call this coordinator, which is essentially like a transaction manager. Again, this is a devoted process to do this orchestration. And it will begin a saga and tell the travel agency the saga ID for that. The travel agency will then call the participants it wants in this saga. So in the travel agency saga, it wants a hotel service and a flight service. When these services are called, the underlying saga library will call to the coordinator and tell the coordinator, okay, join this hotel service in this saga. So now the hotel service and the flight service are part of this saga. If the hotel service and the flight service reply that they are available and everything goes okay, the travel agency will tell the coordinator, okay, the saga is good, go ahead and complete. And the coordinator will go ahead and call the complete methods on the hotel and flight service, okay? And it knows them from when they joined initially, when they joined the saga, okay? Now, if something went wrong in the hotel, there weren't enough rooms in the hotel, whatever, the travel agency tells the coordinator to cancel the saga, and the coordinator will call the compensate methods on the hotel service and the flight service. And so what the hotel service and the flight service had to do with XA and two-phase, they just told the database commit or roll back. Super simple, but we have a locking problem. So we don't have the locking problem here, but we have a burden put on the developer where the developer has to write compensation logic. And what the developer is doing is they're writing a separate table. And I'm putting out a blog on this in the next couple of weeks that has an implementation of this, because everybody talks about it, nobody gives an example. They give an example of the coordinator part, which is the easy thing. The participant part's the hard part. So in the next week or two, I'm putting out an example that I wrote up. But what happens is the hotel and the flight service, they have to keep a separate table to journal the changes that have happened. So the hotel service is like, okay, I took away one room. The flight service says I took away this seat. And then when the coordinator says compensate, it looks at that journal and puts the value of the seat back into the original table, okay? And so you can say how that's a pain, and that's drastically oversimplified, okay? Because then you also have things where you have to handle consistency. So what happened if somebody tried to, and this, let me go back to the scary scenario is the bank transfer. What if money, was put into an account, but it couldn't actually come out of the original account, okay? So now you're showing that there's money in two accounts and somebody else is coming in and looking at that amount. These are things XA handled, but now you have to handle, okay? And I do, again, I sound like I'm selling this blog, but I go into that, the different consistency models and things like that in that. So major pain. So now nobody wants to do microservices with data, but that's why we, that's why I focus exactly on this area, because I see it coming, and I see, people, and we're working a lot with banks now and things like that. So we're working to simplify that, and let me describe some of how we're doing that.
Does it also support choreography and stuff?
Yeah, oh, exactly. So exactly. So what he's saying is choreography is when you don't have a coordinator. And the services, whether they're chaining or what the communication is. Choreography is when there's no coordinator and they're just working out things if it goes wrong. So choreographies are usually better when you'll have like 2 participants. So in this workshop I have a choreographed saga, and it's between order and inventory. So there's 2 parties. The inventory doesn't exist. The order, it tells the order service, it doesn't exist. That order has failed. And they can just talk to each other. So yeah, so you know what you're talking about. Exactly. Yeah. So we've been we've been working on this model because it's probably the more common case is using the orchestrator and the coordinator of this model, especially as the number of participants increase and stuff like that. So there is one specification for sagas out there. There really is no other. And so it makes it the best one. And it's from the microprofile group. And it's the LRA, and you'll see it's very, as far as if you're familiar with JTA and transactions, it's the same transaction types and things like that for demarcating when a saga begins, when it ends, and which methods in the microservice should be called for compensate, as you see here, or complete, okay? And so that's at least made it, nice annotations. You still have to write the compensation logic, but it makes it a nice platform, and there are a few different coordinators out there now. What we actually have 2 products. One is the Tuxedo guys have made a micro T, if you're familiar with Tuxedo transactions, they've made a saga coordinator. And their product actually allows you to do XA 2-phase transactions or sagas. So they kind of give you the option. The other one is the saga coordinator in the database. And the actual original saga spec from the 80s said, this is the way you should do it. You should write the saga coordinator within the database, residing with the data. And you get a number of benefits because of that. So the first column there is roll your own. You get nothing. You got to write all this stuff yourself, the coordination calls and all that, the participant compensation, all that. With the LRA, an implementation of the LRA spec, you don't need to do all the coordination part as far as propagating saga IDs, doing the callbacks and things like that. But you still need to do, but the LRA spec does not support messaging. It's all REST-based. And it doesn't support recovery state being maintained in the participants automatically. So, and then also, just automatic HA that a database would provide. All your data's in the database, so you're getting the HA the database provides. So, in addition to the coordinator in the database and that niceness, we have an auto-compensating data type. And this is like a whole talk unto itself, but what it does is it keeps that journaling for you that I mentioned, but the hotel was this before you called, when you're in the saga. It keeps track of all that for you. And you just mark the table as auto-compensating. And so when it's involved in a saga, it tracks that. And then you do, just like XA and 2-phase, call rollback or commit, and it'll do it for you. So it takes, all that burden, and it does it implicitly for you. So super nice feature. This is just an example of the code simplification because of that. So on the left, this is, very oversimplified amount of code you would have to write for compensation. And then on the right, with these saga APIs in the database, that's literally, what you have to do. You call that, and then you call commit or rollback, just like you would in a JTA transaction. And then we're bringing this support to Spring. So as you may know, there's kind of the 2 worlds. There's the Java EE Jakarta now, and microprofile world, microprofile for the microservices stuff. And then there's the Spring world. And Spring many times is abstractions over the Java world or the Jakarta world, but they have their own mechanisms. And Spring is something like 80% of the market, right, as far as microservice frameworks. And so we're bringing that LRA, again, which is microprofile, therefore it's JAX RS based and not Spring REST based, into the Spring world. So you can run JAX RS in Spring, but that's not what most people are doing. So you can do LRA in Spring now, but we're bringing that and the engine from the database into Spring with these annotations, just the standard annotations. So this is the standard LRA annotation. This is the standard Spring JMS listener annotation. And so you see how that looks similar to the spec, the REST spec one. Okay. Now, 2 more sections. How's everybody feeling? Any questions now, actually, or it's a lot? I know it's.
A lot of acronyms.
What's that?
A lot of acronyms.
Yeah. Oh, okay. The acronyms. Oh, I hate that when people do that too.
I have a generic question.
Of course.
Since the database is now taking care of a lot of this messaging stuff, does that put an overwhelming overhead on performance?
It did, and that was a problem with AQ originally. And that's why it was not so successful up until like 19. So they put a lot of work into that. So now it is, they've compared it against, I think it's, don't quote me on this, but I know it's faster than TIBCO, like they did benchmarks internally. I don't think it can compete with Kafka because they're kind of a different nature to the messaging. But as far as throughput, I know those are the benchmarks that were done because they put a lot for exactly that reason. People were not using it because of the throughput, exactly as you say. Yeah, yep. So that was the big focus in 19, was to make it faster. Yep. So with microservices and especially with all this data stuff, but even without it, we now need to worry about observability more than we ever did before, okay? Because these activities going through all these different processes now, all these different things. So we got to track across the network. We can't just look at 1 or 2 processes anymore. And so real quick, why OpenTelemetry? That's because it's the standard, the CNCF, the cloud standard that everyone follows now. So once some people are starting to follow a standard, then that's, that's good, and that's the thing to follow. So everything we do is based on OpenTelemetry. And so observability, there are basically 3, they call them like 3 pillars of observability. It's good old-fashioned logs, metrics, and then tracing. And tracing becomes probably the most unique and increased in importance as far as microservices, because the tracing, like I say, is across all these processes.
So tracing is where you go through all the logs automatically and fetch the parts that go together to create.
That's one way to do it. Yeah, that's one, and some people do that. Yeah, so there's so many ways to do observability, and that is what some people do, is they just put all the tracing IDs in the logs and then bring the logs together and form a trace from that. Export it that way, or what's common now, like for tools like Zipkin and Jaeger, you use open tracing, which is part of OpenTelemetry, and it sends to a trace collector, a devoted trace collector. And then that trace collector puts the traces together, and then you can view it that way. Yeah. So same idea, really, but you can carry things along the request with the trace and stuff like that. So, yep. And I talk a little bit more about that too with this. Why Grafana is the most popular visualizer. So for visualizing these things, Grafana has made these tremendous strides. And what it does is it now shows you logs, tracing, and metrics in the same console. And it helps, it shows correlations and such. And I'll talk about that in a bit. But Grafana is, the most popular visualization tool. So that's the number one reason. And then what we've done, this is what I've worked on quite a bit the last year, is this unified observability. So the big thing is Grafana is great because it's showing logs, tracing, and metrics. But you'll always see, all these traces, and they're going through the microservice, the Kubernetes mid-tier, whatever, and then they come to the database and it stops, and there's just a node there of database, and it's like, okay, now go into the database and trace through the database. And so what I've worked on is getting those traces, the logs and metrics as well, but also the traces to actually go into the database, and then you can see all the database path that was taken, because a lot of times tracing is used for debugging, but also for performance. And so you make a request into the database and it took a long time. Well, okay, now it's like I say, it's not really telling you much. It just tells you that the database is taking a while. And it's always the database, right? The blaming goes to the database and then to the network, right? The last resort is blame the network. So anyway, this unified observability, the idea is to trace through the mid-tier into the database, the end to end. And so that's probably hard to see, but what this is Grafana. And what you see here is metrics, logs, and tracing. And it's metrics, logs, and tracing all for the same microservice. And I don't know if you can see, I'm going to talk about it a little bit here, but what you see is metrics. And what I did is I drilled down on this order microservice. And this is an order microservice. The Kubernetes microservice is here. The database order schema activity is here. So it's the two tiers side by side. I drill into it to see the logs. The logs are the database side and the Kubernetes server side interspersed, okay? So it's completely chronological across the tiers. Then it picks up the fact, just like you were saying, there's a trace in the logs that automatically drills down, and then you can go to the trace both by the time and the graph there, and look at what's going on, and you can do it in different directions and all. So for debugging this insanity.
Do you mind quickly just doing this with the mouse?
Oh yeah, okay, yeah, exactly, right. So yeah, this is metrics here, this is logs, and this is tracing, right? And this here is the metrics for the Kubernetes, the order service on the Kubernetes side, and the order service or schema on the database side. I drill down in that to get the logs for the two tiers, and the Grafana feature that is nice. Again, it's half of this is Grafana's. It's a Grafana's credit. Is this drill down into the logs, and then that link there to Jaeger brings us to the trace. And again, this trace, the tracing is the really unique part. This trace is going from the Kubernetes layer into the database, and Oracle has all the SQL tracing stuff to take it over from there. I'm just hooking the two together. So this is done via what's called an exporter. So the unified exporter has three exporters. Metrics, this is the most common type of exporter. All the databases have them. It takes information from the database, converts it to Prometheus format, converts it to open metric format, and then gives it to Grafana. I won't do that demo. Log exporter, same idea. It reads logs from your microservice in Kubernetes or whatever in the database, and exports them over to Grafana. And then the tracing is the really unique part, because there are a couple components involved in this, right? You have your app, and then you have to not only send traces from your app, but you need to take that trace and get it into the database. And the way we do that is with this trace agent. And this is an open telemetry standard approach. That's, again, what's great about standards. You have a Java agent, and you can put this on. That's what's cool too, is Java agents, they sit outside the Java class. You just attach them. So this could be a 20-year-old Java application. You don't have to touch it. You attach an agent, and they've become fast so that they're not making an impact on performance. This agent will do two things. It creates a span on the client. Okay, so traces are comprised of spans. And so the tracing agent will create a span for the client side, and it will attach the trace ID to the call made into the database. The database then receives that. And on the database side, we have both push and pull mechanisms. Okay, push is better. Pushing from the database is better. But if there's a problem for security or whatever, we also have a pull mechanism. Either way, it's an exporter that's taking queries from the database, converting them into open tracing format and sending them to a collector. So you're getting, if you can tell here, you're getting traces from the client side into the collector, propagating the trace ID to the database server side, and then that's exporting into the collector. The collector puts them together and you get an end-to-end trace. And what's cool about this too is you can use any type of query. And that's true for the metrics and the logs and the tracing. So you can use, PromQL is based on SQL anyway, but for these, you can use any SQL against the database and build the metrics, logs, and especially the tracing out of it. So that's the API for the tracing agent. I won't go into that. But you'll see here, you can do like any kind of SQL statement to get you information for that. Okay, so only one more section. Bring it home. Yeah, it's 7:10. Thanks for hanging in. It's cool. Appreciate it. Okay, there's the operator has a thing for that. It's okay. So last thing is I want to sell you this new product. I missed that. I wanted to sell him that. So this is the new thing we just put on the marketplace. It's kind of unique because it's two offerings, and one is for mobile. So it's using the Parse platform that LinkedIn or that Facebook just kind of gave. They were doing the mobile thing for a while and they gave up on it. Just donated it to the open source. So we picked that up and we've been using that. But more of my focus here is the Spring Boot backend. And so if you're familiar with Azure's as a Spring Boot offering, ours is better. No, but they've had one, for a while now. So that's, if you know that, then you can get the idea of what we're doing here. But what we're doing that's kind of cool. So this is probably for sure is the most common microservice architecture out there. Okay, it's Spring Boot with the old Netflix Eureka. And I say old because this is not the, I've had labs and all that where we're using service mesh, et cetera, and this doesn't preclude service mesh or anything like that. But a lot of this stuff is the maybe at least 5 years old stuff, but this is what's in use. We're going to what people are using. And it lays all this down automatically for you. So it's the long and short of it, all these common microservice things. And that's an example of the infra you get. Now these, this is both for cloud, Oracle Cloud, but also the other clouds. So everything's multi-cloud, of course, it has to be, and on-prem. So it's not just cloud. But we do have of course, if Oracle, hook up the Oracle stuff, those type of things. And this is the infra. And then this is, I like this is a piece I wrote, is the CLI for it and the corresponding admin server. And it kind of typifies what I really think is powerful that we can do. And that's this one command for the CLI, which is deploy. And so what I do here is all you need to do is provide your microservice jar. It will take the jar, it will create the container image for you. And again, if it will optimize that. So one of the things it can do is attach that trace agent. Okay. And that's with the open telemetry, it's so important to get these traces, but there's a lot of different ways to get that in there. But if the user's just providing the jar, we can optimize it and kind of normalize it that way. So it creates the container image, tags it and pushes it to the image repo, to the container thing. And then I introspect the actual jar itself for annotations, config, and things like that. And I will provision or find or bind, if it exists already, the messaging and database resources it needs, and then wire them up. So it's pretty cool. It just automatically does all that for you and works nicely. Then it creates all the Kubernetes stuff you need, deployment services, secrets, all that, and puts the bindings that you have in your config to the resources that are created. So pretty powerful feature. That's all you have to do is provide your jar and you get all that, and it deploys it to that infrastructure. So I think that's enough. Here are some workshops and some other resources And yeah, thanks. I hope that wasn't too much. I figured I'd lay it all out. And
If anybody has questions online, you can use the chat.
Yep.
So repeat the question though.
Yep, sure thing.
When we have like the messaging communication, we are going through the Oracle API instead of using the other direct API like a Kafka API or JMS API. So we are going to use the Oracle API as if you are talking to the database or do the operation, and the database behind the scene is going to do the really delivering the message to the destination. Is that my understanding?
Yeah, that's correct, except no, it is actually JMS and Kafka APIs. So the JMS.
Okay.
Yeah.
So okay, the Oracle implemented the interfaces of the JMS and Kafka.
Exactly. Yeah, that's right. Yep.
Okay.
Yep.
So
Yeah, the giant JMS ones have been in there for a long time. The Kafka ones are newer, like a year or so. Yeah.
okay, so when it comes to the Kafka, client and non-communication, there are so many things about rebalancing or multiple customers
Right.
subscriber, whether to duplicate it or not duplicate, all those
Exactly.
big complexity of deciding the integration.
Yep.
We still need to do that, but only the connection part will be through this API.
That's
So
right.
all these things will still
Yep.
can do all of the way we can connect today.
That's right. Yeah, exactly. So just repeating the question, how the transactional event queue engine in the database, what APIs do you use? Is it support JMS and Kafka? And what's different and what isn't as far as configuring them on the back end? And the answer is it's you configure Oracle as you would. JMS is completely supported every single area of the spec, but Kafka is a special beast. Yeah, exactly. So for one thing is, I should have made this clear, it doesn't support all the Kafka APIs. Okay, it's the produce. Yeah. So the K streams and stuff like that, but it's the produce, consume, and all that are supported. Yeah. Yep.
Okay, so because that's where when you work on this API, the open source world is going to introduce new APIs faster.
Yes, for sure. Yeah.
We'll be like catching up.
Yeah, for sure. Yeah, exactly. Yeah. Yep. Yeah, definitely
when
not.
it comes to the, even though Oracle is going to do this other transaction management role, that all those things, how that is going to work with the other component? Like we need to be ready to wait to contact say that rollback the message. By the time message may be consumed, or you hold that message until you get the commit.
Oh, so you're saying on the receiving side of you're not talking about sagas, right?
Okay.
That's first.
No,
okay, yeah, right, yeah. Yeah, you're just talking about when the Kafka receives it.
Okay, I'll just put an analogy, right?
Yeah, sure.
So you be the Oracle and Eyal with the Kafka. So I talk to him directly earlier. Now we are going through the API which goes to the giving a connection to Oracle. Okay,
Right.
make sure that I'm doing one database update. Also, I'm sending a message to Eyal. And I say commit, it's all good. After that, only you will send that commit, you will send the message.
Right.
You may have a same challenge of sending but not getting that, not properly delivered, or he may be for a moment that disconnected. So you need to have a guarantee to deliver.
Right.
Do you attempt those things internally? How do you guarantee that this message will be delivered because we committed?
Yeah, because it's using the one thing I just want to make clear is that you're not talking about doing the bridge or connector to Kafka. You're talking about when we keep it all in the Oracle system.
Yes.
Yeah, so that it's using underneath, it's using the Oracle AQ. So, like produce, consume, it's pretty much the JMS.
So basically, you have an intermediate queue,
exactly.
And then make sure they're delivered.
Exactly.
Okay.
Yeah. Yep. Exactly. Yep. I think that got through on that. Yeah. Yep.
That's impressive.
Yeah, those are great. I could tell when we were talking, you knew us. Yeah, it's good questions. Yeah. Yep. So you got all that? You're like, I don't want to do it. Well, what's great, the use cases you guys have are like the best ones because there's such an end-to-end. You won't hit all these, of course, but it hits, I'm sure you'll see more than you'd expect, or
Does the product have those agents that you were talking about for infrastructure stuff more, not just app stuff? So like if you had an ETL kind of process, for example, would you be able to put your Java agent on there and bring that all into the stream there, and it gets put on the Grafana?
Yeah. If it's a Java, I mean, we're writing them for all the different languages. The Java one's the only one done now, but yeah. Yep, for sure. Yeah, it's that Java agent. That's the rebirth. That thing's been around for a while now, right? And it's. I was like, how they? The only way I can think they're doing that is bytecode manipulation, like a Java agent. I'm like, that's exactly what they're doing. Yeah, that's the new idea.
Another question about that, the last slide, you deploy the ECAF deploy, you are basically you give the jar and it generates all the Kubernetes related things like services, obviously.
Right.
So how do you compare that with the Helm chart or things like that? You need to configure a lot of things like, okay, I need to make it highly scalable,
Right.
HPA, and then things like ingress and all those things. Does the product has an ability to configure all those things?
Yeah.
Somehow like
there's a line.
Version?
Yeah, exactly. And there's the line between that deployment admin and the actual like system admin, and that's where we do the scaling for each and stuff like that. Yeah, exactly. But you're right too. There's going to be the whole T-shirt size thing with small, medium, large customers.
Small is basically for simple microservices.
Right, exactly. And here for the small, it's going to be here's the kubectl command to auto scale. Yeah, exactly.
Because like when you say that we give the jar and we generate all this even Docker image, that's a lot.
Right.
Right there.
Yeah, exactly. Yeah. But it is nice because we can get some more control that way too.
So having said that, like how new this product is who's the biggest ecosystem or customer using this one.
Right. So the great thing in Oracle is like half of our, you can get a huge customer in Oracle. So the FSGBU, the financial, they have their own, like so many financials are, they're putting out their own product and it's based on microservices. And this is the chassis for that. So that's the first cost. That counts. It's inside, but that counts. Yeah. And then we have, maybe a few other, I don't think I can probably name customers, but like flagship customers.
How new the product is? Is it totally new
Yes.
2020?
Yep. Yeah, exactly. Yep. Just went on the marketplace, and that's why we're, working it all out and stuff like that now. Yep. So you can, just like all the clouds, I don't know if you know about Oracle Cloud, they have a marketplace, and you can just go there and say install app, and this is on there. Yeah, exactly. So.
It's the challenging part, bringing all the component about tracing all those things together.
Yes, that's my job. All the hard stuff, transactions and observability. Exactly. Yeah, we're recording. I was saying, it's a lot of work. Yeah, great stuff. Thanks. Anything else? Yeah.
I guess just a general question.
Yeah,
from,
definitely.
The sagas. So are these all typically predefined interdependencies, or could they be potentially a saga that's dynamically getting added because of
Exactly.
dependencies?
And that's the big thing when he was talking about choreography. That's the orchestration lends itself to that more. Yeah, exactly. Yep. Yeah. Yeah, everything. Well, I guess it's super obvious, but the more you know ahead of time how the app works, the more you can optimize, and vice versa. Yeah. So, yep, that's right. You can keep adding, and that's the new workflow engine we have is built on top of that. You can see how workflows and sagas have a similar. Here's the workflow for a process. Especially sagas are built to be long-running activities. So I booked the two of these things, and I left the trip open. I come back and do the other. So it's the underpinnings for workflow for process management. They're going to use it for. Yeah. They're doing a lot of cool new stuff with the workflow, and of course AI, everything. I feel cheesy saying AI now because it's like You mean Chat GPT, right? But it's true. A lot of the workflow stuff's doing a lot. They're doing a lot of cool AI stuff with workflows. So.
Okay,
Yeah.
so I think we ran out of questions. Also online, there are no questions. So
Oh, yeah.
I definitely enjoyed this. This was great.
Awesome.
Thank you very
Yeah,
much.
I definitely did as well. Yeah.
Thank you for
Thank
interviewing.
you.
Yeah. Java developers. Thank you. It's cool.
And you got some good feedback coming from online.
Cool.
Thank you everybody for joining us. Thank you everybody coming in person. I hope to see you next time, which may be either, I'm not sure if we have one in April, but either April or May. We will announce it soon enough. Thanks again. Bye-bye.
Thank you.